Imagine standing on a world so close to the sun that it blazes with an unrelenting fury, a planet scorched and silent, yet whispering secrets older than humanity itself. This is Mercury, the smallest and swiftest of our solar system's rocky worlds, a place that feels both impossibly distant and achingly familiar. For thousands of years, its name has echoed through myths, tied to the fleet-footed Roman god who darted between realms. Ancient eyes tracked its fleeting dance across the twilight sky, but only now, with the courage of modern explorers and the ingenuity of machines, are we beginning to unravel its mysteries. Mercury is no mere rock adrift in the cosmic void, it is a survivor, a paradox, a planet bathed in blinding light yet cloaked in enigma. You might see a barren, gray sphere, a smaller cousin to our moon, pockmarked and desolate. But lean closer, and the truth surprises you. Mercury is not a monochrome wasteland. Its surface shimmers with subtle hues. Speckles of cream, beige, and soft gray, as if an artist brushed color across its ancient canvas. Unlike the moon's lifeless pallor, Mercury's face tells a story of resilience. It's a world of extremes, forged in the crucible of the sun's heat, yet holding secrets that defy its fiery surroundings. Composed of roughly 70% metallic materials and 30% silicate rock, Mercury is less a rocky planet and more a gleaming orb of iron, its density rivaling Earth's, second only to our home in the solar system. If Mercury were Earth's size, its gravitational pull would nearly match ours, but its smaller stature, barely larger than our moon, gives it a gentle tug, a surface gravity just shy of Mars. Stand on Mercury, and you'd feel light, almost buoyant, as if the planet itself were reluctant to hold you down. Yet, despite its delicate pull, Mercury's density speaks of a massive, molten core, a heart that pulses with mysteries we're only beginning to understand. Gaze upon Mercury's surface, and you'll see a landscape both familiar and alien. Its craters, vast and deep, mirror the moon's scarred visage, evidence of a bombardment that stretches back billions of years. But look closer, and the differences emerge. Narrow ridges, like the wrinkles of an ancient face, snake across the planet for hundreds of kilometers, hinting at a time when Mercury was alive with geological fire. These scarps, formed as the planet cooled and contracted, tell of a world that once pulsed with energy, shrinking by over 14 kilometers in diameter since its fiery youth. Among these scars lies the Caloris Basin, a colossal wound 1,550 kilometers wide, carved by an impact so cataclysmic it sent shockwaves rippling across the planet. The collision sparked lava eruptions, leaving a towering concentric ring over 2 kilometers high. On the opposite side, a chaotic jumble of hilly terrain, known as the Weird Terrain, bears witness to the sheer violence of that ancient blow. Mercury's surface is a geological diary. Each crater and ridge a page written in the language of cosmic chaos, preserved in a world that has been geologically silent for eons. Yet, Mercury is not just a relic of the past, it is a place of stark contrasts that challenge our imagination. Its surface temperature swings wildly, from a blistering 400 degrees Celsius at the subsolar point to a frigid -173 degrees Celsius on its dark side. With no atmosphere to blanket it, the heat flees as swiftly as it arrives, leaving the poles perpetually chilled, never rising above -93 degrees Celsius. Hidden in the shadows of those polar craters, NASA's Messenger probe uncovered an astonishing secret: water ice, locked in eternal darkness, untouched by the sun's relentless glare. Estimates suggest a quadrillion kilograms of ice lie buried there, a treasure trove for future explorers dreaming of a foothold on this hostile world. Mercury's lack of a substantial atmosphere, replaced by a tenuous exosphere of atoms blasted from its surface by solar wind, means it cannot cling to heat or shield itself from the sun's fury. This exosphere, a ghostly veil of sodium, potassium, and even traces of water vapor, dances away into space, forming a comet-like tail that glows faintly in the night. If you stood on Mercury, you might catch a glimpse of this ethereal yellow glow, a haunting reminder of a planet caught in the sun's unyielding grip. The story of Mercury is not just one of beauty and strangeness, it is a tale of human struggle and ingenuity. For centuries, its proximity to the Sun made it a tantalizing yet elusive target. Early astronomers, peering through primitive telescopes, were baffled by its dance with the Sun. Mercury's eccentric orbit, swinging from 46 million to 70 million kilometers from its star, and its peculiar 3:2 spin-orbit resonance meant it rotated 3 times for every 2 orbits, creating a day that lasts 2 Mercurian years. For years, we thought it was tidally locked, always showing the same face to the Sun, until radar observations in the 20th century revealed its subtle spin. This cosmic waltz made Mercury devilishly hard to study from Earth, its surface often lost in the Sun's glare. Sending probes was no easier. The Sun's gravitational pull turned spacecraft into speeding bullets, accelerating toward Mercury with such force that slowing them down to orbit seemed impossible. Mariner 10, in 1974, managed only fleeting flybys, mapping less than half the planet's surface. For decades, Mercury remained a distant dream, a world too close to the Sun's furnace to touch. Then came a breakthrough, born not from new technology but from a brilliant mind. In 1985, orbital mechanics expert Chen Yen devised a daring plan. Instead of fighting the Sun's gravity head-on, a probe could take a winding, 7.9 billion kilometer journey, looping around the Sun 15 times, grazing Earth once, Venus twice, and Mercury 3 times to bleed off speed through atmospheric drag and gravitational tugs. This audacious path, requiring no new engines or impossible fuel loads, made the impossible possible. In 2004, NASA launched Messenger, a small but mighty probe armed with a ceramic heat shield and a suite of instruments to peel back Mercury's secrets. After a 6.5-year odyssey, Messenger slipped into orbit in 2011, defying the Sun's pull to become the first spacecraft to circle this elusive world. It was a triumph of human persistence, a testament to our hunger to know the unknown. Messenger's images and data revealed a planet far stranger and more vibrant than we'd ever imagined, setting the stage for the discoveries that would follow. This is just the beginning of Mercury's story. Its surface, scarred and shimmering, holds clues to a violent past and a dynamic present. From its molten core to its icy craters, Mercury challenges our assumptions about what a planet can be. In the next part, we'll dive deeper into the fiery heart of this world, exploring the volcanic forces that shaped its surface and the mysteries that still linger in its shadows. For now, let Mercury's stark beauty linger in your mind, a planet that endures, resilient and radiant, under the Sun's unyielding gaze. What secrets does it still hold? And what will we uncover when we return to its surface? Stay with me, and let's find out together. Imagine a world where the ground beneath your feet once boiled, where rivers of molten rock carved valleys and fiery ash rained from a sky that wasn't even there. This is Mercury in its youth, a planet ablaze, caught in the throes of a cosmic inferno. Long before humanity's telescopes turned toward it, before our probes dared to brave the Sun's furnace, Mercury was a cauldron of raw, untamed energy. Its surface, now quiet and scarred, holds the echoes of that violent past, a geological record etched in lava and stone. As we journey deeper into this enigmatic world, we uncover not just a planet, but a story of creation and destruction, of forces so powerful they reshaped a world. I'm Alex McCone, and this is Astrum. Let's step back into Mercury's fiery heart, where the rocks themselves tell tales of a planet that once melted under the Sun's relentless gaze. Picture Mercury billions of years ago, its surface glowing red-hot, a seething landscape where rock turned to liquid fire. When rock is heated to extremes, 600 degrees Celsius, 1,300 degrees Celsius, or more, it loses its solidity, transforming into magma, a viscous, glowing ooze thicker than ketchup but capable of flowing vast distances. On Mercury, this wasn't a rare event, it was the planet's defining act. The evidence is everywhere, locked in the smooth, orange-tinted plains that dominate its surface. Take the Raditladi crater, a relatively young scar less than 1 billion years old, its walls sharp and unweathered. Inside, its floor is strikingly smooth, a stark contrast to the rugged hills that surround it. This isn't mere coincidence, it's the signature of lava. When an asteroid slammed into Mercury, requiring no new engines or impossible fuel loads, made the impossible possible. In 2004, NASA launched MESSENGER, a small but mighty probe armed with a ceramic heat shield and a suite of instruments to peel back Mercury's secrets. After a 6.5-year odyssey, MESSENGER slipped into orbit in 2011, defying the Sun's pull to become the first spacecraft to circle this elusive world. It was a triumph of human persistence, a testament to our hunger to know the unknown. MESSENGER's images and data revealed a planet far stranger and more vibrant than we'd ever imagined, setting the stage for the discoveries that would follow. This is just the beginning of Mercury's story. Its surface, scarred and shimmering, holds clues to a violent past and a dynamic present. From its molten core to its icy craters, Mercury challenges our assumptions about what a planet can be. In the next part, we'll dive deeper into the fiery heart of this world, exploring the volcanic forces that shaped its surface and the mysteries that still linger in its shadows. For now, let Mercury's stark beauty linger in your mind, a planet that endures, resilient and radiant, under the sun's unyielding gaze. What secrets does it still hold? And what will we uncover when we return to its surface? Stay with me, and let's find out together. Imagine a world where the ground beneath your feet once boiled, where rivers of molten rock carved valleys and fiery ash rained from a sky that wasn't even there. This is Mercury in its youth, a planet ablaze, caught in the throes of a cosmic inferno. Long before humanity's telescopes turned toward it, before our probes dared to brave the sun's furnace, Mercury was a cauldron of raw, untamed energy. Its surface, now quiet and scarred, holds the echoes of that violent past, a geological record etched in lava and stone. As we journey deeper into this enigmatic world, we uncover not just a planet, but a story of creation and destruction, of forces so powerful they reshaped a world. I'm Alex McCone, and this is Astrum. Let's step back into Mercury's fiery heart, where the rocks themselves tell tales of a planet that once melted under the sun's relentless gaze. Picture Mercury billions of years ago, its surface glowing red-hot, a seething landscape where rock turned to liquid fire. When rock is heated to extremes, 600 degrees Celsius, 1,300 degrees Celsius, or more, it loses its solidity, transforming into magma, a viscous, glowing ooze thicker than ketchup but capable of flowing vast distances. On Mercury, this wasn't a rare event, it was the planet's defining act. The evidence is everywhere, locked in the smooth, orange-tinted plains that dominate its surface. Take the Radit crater, a relatively young scar less than 1 billion years old, its walls sharp and unweathered. Inside, its floor is strikingly smooth, a stark contrast to the rugged hills that surround it. This isn't mere coincidence, it's the signature of lava. When an asteroid slammed into Mercury. The journey to uncover these secrets was no less daunting than Mercury's own fiery past. When MESSENGER launched in 2004, it faced a challenge that seemed insurmountable, slowing a spacecraft enough to orbit a planet so close to the sun's gravitational pull. The solution, born from Chen Wanyen's ingenious calculations, was a cosmic dance spanning 7.9 billion kilometers. MESSENGER looped through the solar system, skimming Earth, Venus, and Mercury itself, using their atmospheres and gravity to shed speed like a ship tacking against the wind. When it finally entered orbit in 2011, it was a triumph of human persistence, a moment when we reached out and touched the untouchable. Over 4 years, MESSENGER captured over 200,000 images, far surpassing the 1,000 scientists had hoped for, mapping Mercury's surface in vivid color and detail. It revealed a magnetic field, weak but dynamic, generated by a molten core that defies the planet's small size. It detected energetic bursts of electrons, mysterious events concentrated in the northern hemisphere, and confirmed the presence of volatile substances, potassium, magnesium, sulfur, that challenged everything we thought we knew about rocky planets. Mercury, it turns out, has more in common with Mars than with Earth or Venus, rewriting our understanding of how our solar system formed. As Messenger orbited, it faced Mercury's brutal environment, swinging from 200 kilometers above the surface to 15,000 to escape the planet's reflected heat. Its ceramic heat shield and solar panels, used like sails to catch solar radiation and slow its descent, were marvels of engineering. Yet, even this resilient probe had its limits. On April 30, 2015, after a decade-long journey, its propellant nearly gone, Messenger fired its thrusters one last time, extending its orbit until it could no longer resist Mercury's pull. It crashed into the surface, leaving a new crater in the planet's ancient landscape, a final mark of humanity's presence. That impact, though, was not an end but a milestone. Messenger's data continues to fuel discoveries, and as we await the arrival of ESA's BepiColombo mission in late 2025, Mercury's mysteries beckon. What forces shaped its fractured crust? Why does its magnetic field defy expectations? And what other secrets lie hidden in its scorched terrain? In the next part, we'll venture beyond Mercury to Venus, a world of beauty and terror, where clouds of acid hide a surface as deadly as it is mesmerizing. For now, let Mercury's fiery past linger in your heart, a planet born in chaos, yet enduring, a testament to the resilience of worlds and the curiosity of those who seek to know them. From the scorched, resilient surface of Mercury, we now turn our gaze to a world that dazzles with deceptive beauty, a planet that seems to promise love but harbors a heart of fire and acid. Venus, our closest planetary neighbor, glows like a beacon in the evening sky, its soft, creamy clouds veiling a reality so harsh it defies imagination. Named for the Roman goddess of love, Venus is a paradox, a serene crescent from afar, a hellscape up close. Beneath its thick, suffocating atmosphere lies a surface where temperatures soar to 462 degrees Celsius, hot enough to melt lead, and pressures crush with the weight of an ocean's depths. Yet, this deadly world has captivated humanity for centuries, its brightness mistaken for UFOs, its secrets hidden behind an impenetrable shroud. I'm Alex McCone, and this is Astrum. As we descend through Venus's clouds and journey onward to Earth and Mars, we'll uncover the stories etched in their surfaces, tales of fire, water, and the relentless human spirit that seeks to know them. Imagine drifting toward Venus, your spacecraft slicing through its upper atmosphere, a thin haze at 250 kilometers above the surface. At first, it feels almost Earth-like, with temperatures swinging between -37 degrees Celsius and -143 degrees Celsius, but the air betrays a sinister truth. Carbon dioxide dominates, a hint of the inferno below. As you descend to the cloud deck at 60 kilometers, the world turns mustard yellow, thick with sulfuric acid droplets that reflect sunlight, making Venus the second brightest object in our night sky. These clouds, whipped by winds reaching 300 kilometers per hour, circle the planet every 4 days, hiding a surface no human eye could pierce without help. Lower still, at 50 kilometers, conditions briefly mimic Earth, tolerable pressure, familiar gravity, but the air is poison, corrosive and unbreathable. Then, the real hell begins. The atmosphere thickens into a supercritical fluid, a strange state between liquid and gas, pressing down with 92 times Earth's pressure. The heat climbs to 464 degrees Celsius, and the winds slow to a sluggish crawl, as if wading through a molten river. The Soviet Venera probes, brave pioneers of the 1970s, survived mere hours in this crucible, sending back grainy images of a desolate, yellow-tinged landscape. Flat lava plains, hardened from ancient flows, stretch endlessly, eroded by an atmosphere that never relents. Venus is a world frozen in time, its crust 300 to 600 million years old, untouched by plate tectonics but reshaped by a cataclysmic resurfacing event that drowned 80% of its surface in lava. Venus's surface is a gallery of extremes, 167 volcanoes over 100 kilometers wide, rivaling Earth's largest, and 900 impact craters, none smaller than 3 kilometers, as smaller meteors burn up in the dense atmosphere. Radar imaging, piercing the clouds, reveals a world of colossal volcanic activity and vast lava seas, a testament to a planet that once boiled with fury. Yet, Venus holds mysteries that tug at our curiosity. Why does it lack a magnetic field, despite its Earth-like size? A 2017 study suggests the absence of a massive impact, like the one that birthed Earth's moon, may have stilled its core's dynamo. At its poles, double-eyed vortexes swirl, defying explanation. Their shapes shifting in less than a day. And then there's the tantalizing question of phosphine, a gas detected in 2020 that sparked whispers of microbial life in the clouds, only to be disputed and rediscovered in 2023. As missions from NASA, ESA, Russia, China, India, and even private ventures prepare to revisit Venus in the coming decade, the possibility of life, however faint, ignites our imagination. Venus, both sister and stranger to Earth, reminds us that beauty can hide terror, and that even the most hostile worlds may hold secrets waiting to be unveiled. Now, we turn homeward to Earth, a jewel in the cosmic void, its blue oceans and green continents a singular marvel. From space, it's a breathtaking sight, a planet alive with water, oxygen, and the pulse of life itself. Yet, even our home remains a mystery in many ways. Earth's surface is ever-changing, shaped by plate tectonics that churn beneath a thin crust, forging mountains, volcanoes, and trenches. Its oceans, vast enough to cover the planet 3 kilometers deep if smoothed flat, drive a water cycle that nourishes life from bacteria to humanity. The atmosphere, a delicate balance of nitrogen, oxygen, and trace gases, shields us from solar storms and burns up meteors, while the ozone layer guards against ultraviolet rays. Earth's magnetic field, born from a molten core of iron and nickel, dances with solar winds to paint auroras across the skies. Our moon, Luna, looms large, its gravity tugging at tides and perhaps fueling the tectonic activity that keeps Earth fertile. But Earth's perfection is fragile. Its axial tilt of 23.5 degrees gifts us seasons, yet its precise orbit, 365.25 days around the Sun, requires leap years to keep time aligned. Ancient minds, from Eratosthenes to Copernicus, pieced together Earth's place in the cosmos, and today, we stand on their shoulders, marveling at a planet that balances chaos and harmony to cradle life. Finally, we arrive at Mars, the red planet that has long fueled our dreams of exploration. Its rusty hue, born from iron oxide, paints a rugged landscape of towering volcanoes and canyons that dwarf Earth's. Olympus Mons, 3 times taller than Everest, rises 22 kilometers, its gentle slopes a testament to Mars's weak gravity, only 38% of Earth's. Valles Marineris stretches 3 times the length of the Grand Canyon, a scar that speaks of ancient upheavals. Mars's day, just 24 hours and 39 minutes, and its 25 degrees axial tilt give it seasons like ours, with polar caps of water and CO2 ice that wax and wane. But Mars is no twin to Earth. Its thin atmosphere, 96% carbon dioxide, offers little warmth, with temperatures plunging to minus 143 degrees Celsius at the poles and climbing to 35 degrees Celsius at the equator. Once, rivers flowed here, carving dry riverbeds, but 4 billion years ago, its magnetic field faded, and solar wind stripped away its atmosphere, leaving a world of dust storms and geysers that erupt in spider-like patterns as CO2 ice sublimates. NASA's rovers, Viking, Spirit, Opportunity, Perseverance, have brought Mars to life in stunning 4K, capturing avalanches, dust devils, and fresh craters where water ice once flowed. Mars's moons, Phobos and Deimos, tiny and irregular, cast fleeting shadows, their eclipses a haunting reminder of a world both alien and familiar.